By the end of this lesson, you should be able to solve a system of equations by graphing. So a system of equations are two or more linear equations involving the same variables. And then the solution is a pair of numbers that work in both equations. So what we're going to do in this example is I'm going to graph these two equations, y equals 2x minus 2 and y equals negative x plus 4. Let's graph this first equation in red. The y-intercept is negative 2, and then the slope is 2, so it means I'm going to go up 2 over 1. So let's see, from the y-intercept up 2 over 1, then I'm just going to keep that going. Okay, so that's going to be this line right here. Okay, and then let's graph this line. It has a y-intercept of 4, and then a slope that's a negative 1. Negative x has a slope of negative 1. So I'm going to go down 1 over 1. So here's all the points that work in this equation. And we'll graph that line. I missed it a little bit, didn't I? Let's undo that. All right, so that's that line. This point here that they have in common, so you look, they have this point in common. All right, that is the solution to both equations. So that is the point, let's see, 2 for x and 2 for y. So if you substitute those into the equation, so if we substitute into this one first, I'm going to put 2 in for y, I'm going to put 2 in for x, and let's see, I get 2 equals 4 minus 2, so I get 2 equals 2, so it works in that equation. So again, that's the red equation. So any point from that I would choose from that red line would work in the red equation. But if the only point that works in both, though, is going to be that point they have in common. So let's substitute 2 into this equation. Let's see, I get 2 equals negative 2 plus 4 is 2, and it works in that. So if you look, my answer is the point 2, 2, or where x equals 2 and where y equals 2. And that's the point that works in the blue equation and the red equation. So if we look at a system of equations, you have 3 choices. So the number of solutions depends on your lines. All right, so if you look at this table, it can be where they intersect. So right here would be my solution. Okay, that's the point where the lines intersect. I could graph them and it could end up being the same line. So then we would have infinite solutions. If my lines are parallel and they never intersect, then there isn't a solution for both. So we say there is no solution to the system. So your choices are one solution, infinite, or no. Most of your equations for this lesson will have one solution, so where the lines intersect. We will use Desmos as a tool to help us graph our equations. Okay, so if we look at this first example, I went to Desmos.com and I graphed y equals negative 2, and that's this line here. All right, those are all the points where y equals negative 2. And then I graphed this line here. Those are all the points where if I multiply 3 times x and subtract y, I get negative 1. And then my solution is here. The solution is where they overlap, which is negative 1, negative 2. So negative 1 and negative 2 work on both equations. Negative 2 equals negative 2 if we substitute in the first equation, and then 3 times negative 1 minus a negative 2 would give us negative 1. So we're going to, when we do our solutions for this lesson, we're going to transfer the graph over, and we'll also write down the point. So the best way to do it is using where they intersect, so negative 1, negative 2. Okay, that's the point where they intersect. The y-intercept of my horizontal line is negative 2, because they're all negative 2. And I'm going to graph that line. I'm going to try my best at graphing that line. Well, I try my best. And then we'll graph the other line using his y-intercept, and his y-intercept is negative, or is positive 1. So I'm going to put that there and graph that. All right. And then they intersect at negative 1, negative 2. All right, let's look at the next example. So we're going to graph x equals 2, so all the points where x is 2, that's a vertical line. That's this line right here in red. And then we're going to graph the line where 2 times x plus y will equal 1, and that's the blue line we have here. And then the point that works in both is the point 2, negative 3. All right, if you substitute it again, 2 equals 2 for the first equation, and 2 times 2 is 4, plus the negative 3 would be 1. All right, so let's transfer that graph over. So first let's write the solution is 2, negative 3. Then we're going to put that point here, so 2, negative 3. All right, the y-intercept of the blue line is at 1. And then the x is just a horizontal line, so that only has an x-intercept. All right, so let's graph that line. And then we'll graph that line. Okay, so again, 2, negative 3 works in both equations. And you can use Desmos as a tool to graph your lines. All right, the next example, y equals half x. And then when I add x and y, I get 3. So I graph those two lines, typed them into Desmos, and I get the point 2, 1. And if you look, a half of 2 is 1, and 1 plus 2 is 3, so it works in both. So I'm going to graph the point 2, 1 on here, which is my solution. Right. And then the y-intercept of the black line is 0. And the black line is y equals 1/2 x. It has a y-intercept of 0. All right, and then the other line has a y-intercept of 3. And then graph that. All right, let's look at example 4. Again, type them in the Desmos, and then I click on where they intersect, and it gives me the point of their intersection is 1, 4. Again, so that's the solution to my system of equations. So I'm going to graph the point 1, 4. The y-intercept of the blue line, which the blue line is going to be this equation here. Okay, there's our blue line. So that crosses at 2. And then the y-intercept is 6. So 1, 2, 3, 4, 5, 6. All right, graph that and graph that. That is poor. I'm going to do a better job. Hopefully you have a straight edge. And then finally, let's talk about what it looks like when they're parallel lines and there's no solution, and when they're one line and you have infinite solutions. So if you look at example 5, when I graph that, they are parallel. That means they have the same slope. And the slope of the first equation would be negative 2/3. No, sorry, negative 3/2. And that would also be the slope of the second equation, negative 3/2. So let's copy them over. And you just can get a couple points. So this one has a y-intercept of 3. And then, like I said, we go down 3/2. So that's equation number 1. And then this one has, it's going to have a y-intercept of -2. If you look in Desmos, it would have it. And then there's its slope. So we're going to write that this has no solution. Okay, again, those are equations that have the same slope but different y-intercepts. If we look at number 6, when I graphed them, they overlapped each other. And if you look, all the first equation is the bottom equation multiplied by 2. So 2 times y, 2 times -2 is -4x, and then 2 times 2 is 4. So they're the same equation, just one is what we call it has been scalar multiplied. So I've multiplied everything by 2, but that means the equation stays the same. Okay, so if I multiply the whole equation, remember if you multiply both sides of the equation with the same number, it stays balanced. So this has infinite solutions because it's one line. Okay. And the y-intercept is 2, and then it goes down to over 1. And there's that line. So what you're going to do now is complete the examples on the next page. Those are problems 5 through 13. And you're going to graph each system on the paper, determine the number of solutions, so tell me if it's infinite, no, and if it has the solution, tell me what it is. So that's examples 5 through 13 on the other side of the sheet.